Welcome to day 2 of our notes on Unit 5, multiplying/dividing complex numbers and rationalizing. If you look at our first example of many when we're going to simplify, we have a square root of -14 times 2, which is kind of a square root of 2. So the first thing you have to do when you have a negative under the square root is you need to take out the I first. So by doing so, this gives me I square root of 14 times 2 square root of 2. And then I'm going to multiply like I normally would. So I have 2I times the square root of 28, because 14 and 2 gives you 28. Then I'm going to simplify radical 28 like I normally would. So this is 2I. This breaks down into 4 and 7. Square root of 4 is 2. 2 times 2 gives me 4, so this is 4I square root of 7. And that's our final answer. So when we look at our next example, again, take out the negative first and make it an I. So I have 3I square root of 7 times I square root of 7. So when we multiply, I have 3I squared, and then the square root of 7 times the square root of 7 is just 7. So 3 times 7 gives me 21, and as we know from our first day of notes, I squared is -1, so I will get -21 as my answer. Now, it's very important that we take out the I, especially in an example like this, or take out the I first, I should say, especially in an example like this, because otherwise I would get the final answer off by the wrong sign. It would be positive 21 instead of -21. So, very important. So then for 3, you would have I square root of 4 square root of 5 by breaking down my 20 times 4 radical 5. Square root of 4 is 2, so I have 2I square root of 5 times 4 square root of 5. So 4 times 2 gives me 8. Square root of 5 times square root of 5 is just 5. So this simplifies to 40I. Okay, so if you look at examples 4 through really 7 here, I have two binomials being multiplied. You're just going to FOIL like you normally would. So I have 2 times 3 gives me 6 plus 15I from my inners here. My outers are going to give me -8I, and my lasts are going to give me -20I squared. So now, combine your like terms. So 6 plus 7I. Don't forget that this is going to give you a -1, so this is really plus 20. Putting it into a plus bi form, this gives me 26 plus 7I as my answer. If you look at 5 and 6, notice that I have plus, minus, and everything else is the same. So this is reminiscent of our difference of two perfect squares, where when I multiply the firsts, I get 1, I get plus 2I, minus 2I, and lastly, minus 4I squared. So my middle terms cancel, or reduce to 0, so I have 1 minus 4 times -1, which simplifies to 5. Okay, so my inner and outer terms drop out, and I'm left with just my first and my last. I squared becomes -1, so I'm left with a real number. Now, just to be sure we're getting this vocabulary right, this is an example of a complex number as well, because everything stems from complex numbers. I start with complex, then I either go to the real or I go to imaginary. And from real, I have either rational or irrational. So 5 just happens to be an example of a rational number, which is a real number, which is also a complex number. So just make sure that we're paying attention to that. And this whole flow diagram is really on the first page of our notes from day 1. Just going to erase that. Okay, so then if we look at 6, but keep in mind it's another difference of two squares. So really, I only need my first and my last. So I've got 25 minus 9I squared. So this is the same thing as 25 plus 9, because I squared is -1. So 25 plus 9 gives me 34. So another complex number that is both real and rational. Okay, another example where we're going to FOIL. Now I have a square root in there. That's fine. So, whoops, I'm going to do my first, outer, inner, and last. So I have 4 plus 3i square root of 2. My last are giving me minus 4i square root of 2. Oops, my I got messed up here. And then my last gives me minus 3i squared times 2, because the square root of 2 times the square root of 2 is just 2. I'm going to clean it up a bit. So I have 4 minus I square root of 2. Then I have minus 3 times negative 1 times 2. So this is all going to go to a positive 6. So I really have 4 minus I radical 2 plus 6. So 10 minus I radical 2 is my final answer in a plus bi form. Okay, my last example here. Here's a little refresher of our powers of I. I'm going to simplify it first before I go forward and distribute. So I to the 6th is the same thing as I squared. I to the 9th is the same thing as I. Okay, well 9 divided by 4, I have a remainder of 1. And then minus 7, 4 goes into 4 evenly, so I to the 0. Minus, this is dots, so this is 36 minus 4i squared. Okay, I'm going to simplify. I've got I squared, which is negative 1, times 3i minus 7. And that's 7 times 1, really, because anything to the 0 power is 1. And 7 times 1 is just 7, well, negative 7. And then minus 36 plus 4i squared. Okay, so now remember, I squared is negative 1. And I'm going to distribute my negative 1 here. So I have negative 3i plus 7 minus 36 minus 4. And that's because, again, I squared is negative 1. So when I combine everything, I'm going to get negative 33 minus 3i as my final answer. Okay, so that's just practice simplifying, working more with I. And when we come down here to this little table, we're going to work with rationalizing complex numbers. And by complex, we really mean imaginary here, because technically real numbers are complex numbers. So the stuff on the left is not new information. You guys know how to do this from previous units. Or if I'm going to rationalize 7 over the square root of 3, I'm going to create a perfect square in the denominator so that I get a rational number in the denominator. So I have 7 radical 3 over 3. In the second example, I need to get rid of the square root of 5, so I'm going to multiply by what we call the conjugate to create a rational number in the denominator. So I have 2 minus 2 radical 5 all over 1 minus 5. Okay, just like our dots in the previous problem, my inner and outer terms will drop out, so I'm left with 1 minus the square root of 25, which is just 5. So when I simplify this, I'm going to get 2 minus 2 square root of 5, all divided by negative 4. And I can go ahead and divide everything here by 2. And by negative 1. So this leaves me with negative 1 plus 1 radical 5 divided by 2. So, just like we can't have a square root or radical in the denominator of a fraction, we also can't have an imaginary unit. So I'm going to create a rational number in the denominator. And by the way I'm going to do this, I'm going to zoom in here, I can multiply the top and the bottom here by I. Now by doing so, I've created an I squared. And we all know that I squared is the same thing as negative 1. So by doing so, I get 7i divided by negative 3, which is now a rational number. And just writing it with the negative at the top, I have negative 7i all over 3. This is rationalized. So down here at 2 divided by 1 minus I, There's a reason we put it parallel to this example. I'm going to multiply by the conjugate of this denominator. So I'm going to multiply by 1 plus I. Okay, so my numerator goes to 2 plus 2I divided by, now because this is a difference of two squares, I'm going to have 1 minus I squared. So 1 minus I squared is the same thing as 1 minus a negative 1, which just goes to 2. So this is 2 plus 2I divided by 2, which then simplifies to 1 plus I. And that is completely simplified and rationalized. Ooh, okay, so moving on to our next page, we're going to practice simplifying, and we're going to rationalize where necessary. So our first example, I'm going to do it a couple different ways. When I'm looking at this expression, the first thing my eyes go to are the 6 and the 18. I can simplify that to 1/3. Next, I'm going to simplify the I to the 15th. So I to the 15th simplified, 15 divided by 4 is going to have a remainder of 3. And 18 divided by 4 is going to have a remainder of 2. So I'm going to rewrite this as I to the 3rd divided by 3I squared. When we simplify this, I get negative I divided by 3 times negative 1. Now your negatives go to positives, so I have I over 3. And that's completely fine the way it is. I don't have an I in the denominator. We're completely rationalized, so we're good. The other way we could do this is recognize that 6 I to the 15th all over 18 I to the 18th is the same thing as is the same thing as 1 over 3 I to the 3rd, just by using my exponent rules. If I'm canceling out 15 up here, I would cancel out 15 down here and be left with 3. Okay, so I can't leave I to the 3rd in the denominator. I'm going to just simplify this first, though. I have 1 over negative 3I, and that's because I to the 3rd is the same thing as negative I. Can't leave the I in the denominator, though, so I'm going to multiply the top and the bottom by I. So I get I over negative 3I squared, which negative 3, or I squared is equal to negative 1. So I'm left with I over positive 3. So notice I get the same exact answer as I did before. I over 3, I over 3. So either solution method is good as long as you're rationalizing in the end on the last one. Okay, so when I look at number 2, this is like our example from up here. I have to multiply by the conjugate. So the conjugate in this example is going to be 6 plus 5i. So I'm going to FOIL my denominator, or really it's going to be my first and my last because my middle and my inner and outer terms will cancel, and I'm going to distribute my 5. So I've got 60. Oops, not 60. What am I doing here? I have 30 plus 25i divided by 36 minus 25i squared. Now remember, I squared is the same thing as negative 1. So I really have 36 plus 25, so this is 30 plus 25i divided by 61. And that's fine the way it is. Notice my numerator is always in a plus or minus bi form as well. Okay, so when I come down to number 3, multiply by your conjugate. So you've got 3 minus 4i. Okay, I'm going to FOIL both the numerator and denominator. So I have in my numerator. Oops. Okay, I'm just going to FOIL. Okay, so this was a difference of two squares in the denominator, and I just FOILed this all out. Then I'm going to combine my like terms. Keep in mind that I squared is negative 1, so it becomes a negative 12, all over 9 plus 16. And again, that's because this is negative 1. Clean it up. So I've got 25 in my denominator. 3 minus 12 gives me negative 9. And then I still have the minus 13i. And nothing else can be reduced there, so that's my final answer. Okay, so when I have question 4, I've got 4 minus 2i divided by 1 plus I. So you're going to multiply by the conjugate again. FOIL your numerator. Okay, first and last in my denominator because I'm using the conjugate. So I got, let's see, this is negative 6i, so I have 4 minus 6i minus 2 because I squared is negative 1, all over 1 minus a negative 1 is positive 2. So this yields 2 minus 6i divided by 2, which is then 1 minus 3i. Perfect in a plus bi form. Okay, one more example. Okay, the conjugate in this example is going to be 2 plus I radical 3. So not only am I going to get rid of the square root, I'm going to get rid of the I as well. So when I FOIL, well, I'm going to distribute my numerator. I've got negative 18 minus 9i square root of 3 all over 4 minus I squared times 3. Clean it up. Okay, don't forget that this is going to be a negative 1, so negative 1 times 3 is a negative 3, but then times a negative 1 goes to positive 3. So this goes to negative 18, minus 9i square root of 3 divided by 7. Nothing else there can be simplified, so this is your final answer. Okay, so you're going to always get rid of the imaginary units in the denominators, just like how you do square roots. And just really more working with I. Don't forget that you're going to combine like terms and I, like treat it like a variable. And from there, there's really not much else to it. Okay, so zoom it out. So this is everything you guys, for those of you who missed class due to the field trip, this is everything you guys missed. I'm going to post the homework on WITS as well.